Good afternoon, everyone. Today we'll be presenting a paper which was named A Brief on the Construction Planning of Burj Dubai Project in Dubai, UAE. The authors of this paper were Ahmad Abdulrazik, Kong Jim King, and J.E.H.O. Kim. Me, Sulaiman Amr Abu Samra, and Amr Mustafa, my colleague, will be presenting a summary for this paper today. Let's start with an outline of our presentation. Our presentation will be divided into three main parts. The first part is the summary for the paper, the second part is a critique, and finally an article evaluation. The first part, which was the summary of the paper, is divided into an abstract for this paper, the introduction, the structural system brief description, followed by a construction of the tower superstructure. Then comes the planning for the concrete work and the technologies implemented for this plan, a site logistic plan, technologies used to achieve the 3-day cycle, finally the major equipment section which was used for this project. Then comes the conclusion of the paper and our critique and article evaluation from our point of view. Let's begin with the abstract. Burj Dubai will be the tallest structure ever built. It will extend up to more than 700 meters tall, which will contain more than 160 floors. It has an integrated aerodynamic shaping and wind engineering for the tower design. The integration of the structural system from both the design and construction perspective is also taken into consideration in order to reach the stable tower. And finally, the main concern in this paper will focus on the construction planning of the tower and what are the activities and how the plan was done for finishing the tower within the 48 months, which is a very tight schedule. Well, going to the introduction section. General information about Burj Dubai that it's a multi-use development tower which contains residential, hotel, commercial, offices, entertainment, shopping, leisure, and parking facilities. The total floor area for this Burj was 460,000 square meters. This is a picture for the Burj as you can see at night. Going to the contract's perspective, the client for this project was A'mar Properties, while the construction manager was Tuner International, and finally the general contractor was Samsung Joint Venture, which was a joint venture between Samsung Korea-based contractor Bisex, Belgium-based contractor, and Arab Tech-based Dubai-based contractor. Leaving the contracts and going to the design originated from the desert flower geometries, where the desert flower is indigenous to both the region and pattern system embodied in the Islamic architecture. Here is a picture for the desert flower where Dubai Tower design was originated from. An overview about the design. The tower was organized around a central core with 3 wings. Each wing consisted of 4 bays, where at each 7th floor and outer base peels away the structure spirals into the sky in order to reduce the cross-section. A floor plan is characterized with a U shape in order to maximize the view and provide the tenants with plenty of the natural light. Here is a picture showing the U shape. As you can see here, a central core is surrounded with 3 wings and each wing has 4 bays as shown in this plan. So leaving the design, going to the materials used to achieve this design, there were 2 materials used in Burj Dubai project. The first one was the reinforced concrete, high performance reinforced concrete from the foundation to level 156, and then the structural steel braced frame was used from the 156 level to the pinnacle to the end of the tower. As you can see here are the different materials used for Burj Dubai project. From the wind engineering perspective, The wind engineering principles were integrated with the architectural design of the tower to result in a stable, dynamic response to resist the powerful wind forces. Moreover, as the tower spirals into the sky, the tower's width and shape diminishes and therefore reduces the wind dynamic effects, movement, and acceleration. So, this is a picture showing how the cross section differs as the tower spirals in the sky and how the width and length diminishes as it spirals in the sky. Leaving the introduction, going to the structural system description. Firstly, the lateral load resisting system consists of a high performance reinforced ductile concrete walls where the walls are linked to an exterior reinforced columns, and at the top of the spire diagonal structure and steel bracing system was done in order to resist the lateral load system. This figure shows the nodes and column slabs and the wings and slabs and finally the core. As you can see here, this is the structural system that resists the lateral loads and that resists the loads derived from this super tall structure. Followed by a floor framing system. The residential and hotel floor framing consists of 200 mm to 300 mm two-way reinforced concrete flat slab which spans up to 9 meters. At the tip of the tower, the flooring system consists of 225 mm to 250 mm two-way flat slab. And finally, within the inner core, the floor system consists of a two-way flat slab with beams. This picture shows the floor framing system at different levels, where the cross-section and the structural flooring system differs as the tower spirals into the sky, as shown in the figure. Leaving the flooring system, going to the foundation that founded this super tall building. The foundation was founded on 3,700 mm thick high performance reinforced concrete piles supported with a raft foundation. This raft foundation utilizes self-compacting concrete which was placed over 100 mm blinding slab over waterproofing membrane, and all the rafts were protected with a waterproofing membrane to resist any groundwater from coming for this raft. And finally, the pile diameter were 1,500 high-performance reinforced concrete board piles where it extended to 45-meter depth. So this figure would be a great illustration that shows you the foundation, the raft foundation, as you can see, and the places where the piles were extended to 45-millimeter depth. Leaving the structural system, going to the construction of the tower superstructure. Well, the goal for the tower superstructure was that the project has to be completed within 48 months, which from my moderate point of view is a very, very tight schedule. So, certain technologies has to be implemented to reach this target within the time. The first technology that was planned for a 3-day cycle for the structural work. For reaching this target, an optimum formwork system and optimum transportation system has to be taken into consideration to finish the structural works within 3 days for each level. Moreover, an organized logistic plan for day-to-day activities has to be taken into consideration in order to finish within this limited time. Finally, applying all the advanced high-rise construction technologies has to be done in order to finish within this budget and within this time. So, each and every one will be described in more details within the following sections. This picture just shows the current construction progress of Burj Dubai and how the tower crane were implemented and how the materials were prefabricated and what is the project. Going to the planning for the concrete works, which was a main factor that has to be taken into consideration because the concrete is the material carrying the loads in the system. Concrete testing and quality control programs were put in place before the tower construction. Well, Owner Independent Testing Agency's IVTA was responsible for the concrete testing from the concrete supplier Unimix. Finally, the program started from the early concrete mix development up till all the test programs completion in order to assure a high quality concrete. From the testing program that has been implemented are the trial mix design, mechanical properties of the concrete, durability test, creep and shrinkage test, water penetration and rapid chloride permeability test, pump simulation test, which was one of the most important tests that was done for this Burj Dubai project, heat of hydration analysis and tests. Leaving the concretes and going to the site logistic plan. The site area of Burj Dubai was 105,600 meters square, and encompassing the tower, it was divided into 3 zones: Zone A and Zone B and Zone C, which will be shown within a few seconds. The site logistic plan reflects the effect of the current construction activities, laydown areas, and site traffic circulation on the surrounding zones. This picture shows the Burj Dubai in different zones that were surrounding the Burj Dubai project and construction and laydown areas. Going to the technologies that were used to achieve a 3-day cycle. A 3-day cycle, from my point of view, is a dream, which was reached by Burj Dubai. Due to the very tight schedule, key construction technologies were incorporated to achieve a 3-day cycle set for the concrete works. These are the technologies that were implemented to reach this 3-day cycle. Firstly, an optimum formwork system, auto-climbing formwork system ACS, which was designed by Dhaka, a rebar prefabrication on the ground level, high performance concrete that sets quickly to finish within the 3 days, advanced concrete pumping technology, simple drop-head formwork system, column wall proceeding method. So each and every single technology will be discussed in details for the following sections. Coming to the construction and auto-climbing formwork system sequence. The ACS is divided into 4 sections, consisting of the center core wall, followed by the wing walls, and finally the 3 tower wings. Well, the construction sequence was as follows. Firstly, a central core wall, followed by the central core slab, then come the wing wall and the wing flat slab, finally the nose column and the nose flat and flat slab, and finally the multi-story outrigger walls. As shown in this picture, this is the central core wall and the outer slab of the center core, followed by the wing wall and the typical wing slab, and finally the wing slab and columns are constructed. The central core is always exceeding the wings and the nose in order to be able to get the tower to use the tower crane more effectively. Actually, the tower crane is not the tower crane. This also picture shows that there are 3 tower cranes in the central core and the wing core column and slabs, the formwork of them, and finally the nose column and slab, using the drop head prop system, which will be described later on. A problem faced the construction engineers regarding the outrigger walls because of the conjunction of the reinforcing bars at the connection zones, because it was complex and it took high time. So the problem was simply solved by replacing these reinforcement bars with a structural steel section to resolve the design forces more effectively at the joints, ensuring the joint integrity. I'd like to draw your attention that this video you could visit and see the construction sequence and the ACS sequence of constructing the slabs. www.youtubecoach.com. This is describing the auto climbing formwork system designed for Burj Dubai. Going to the rebar prefabrication. The reinforcement bores were prefabricated at the ground level, resulting in quality control advantages, reduction in number of workers found in each slab, and speeding up the vertical element construction time when the rebar is assembled in a double-story modules. So you can just reassemble the rebars in double-story modules, not for one story, for 2 stories, in order to speed up the vertical element construction time. This is the rebar prefabrication process, where it's prefabricated at the ground level and it's assembled to the level required. Then come the composite link beams, which was not only used for connecting the vertical core wall rigidly for the lateral load-resisting system, but it was also used as means of transferring and equalizing the gravity loads between the vertical members, the cold wall elements, and the nose columns. Due to the large shear and bending moments, the link beam were designed to be composite between steel members encased in high-strength concrete in order to resist the loads. Here comes a picture showing how the installation for this composite beam and how it was lifted from the ground level, as you can see in the picture. Going to the slab formwork system, the Meva deck drop head slab formwork system was used for the slab construction. It was chosen due to many factors such as installation simplicity, panel formwork material and strength, prop strength and stiffness, system flexibility and suitability for the slab hanging geometry, and finally camping allowance. The slab formwork system is as follows. This is the drop head prop, as you can see in the picture, with a height of 190 mm, and a protection system was executed before installation. Also, the slab shoring system consisted of 4 levels of shore and 1 level of reshore in order to control the maximum load on the lower level slabs. As you can see in this picture, the day-to-day progress of the formwork system for the slabs. The day 1 is the rebar was completed and the concrete was poured, and then day 2 was erecting the prop and panel and removing the panels after 24 hours or achieving a 15 megapascal load. Finally, the formwork was completed and the rebar was also done, reshoring the props, and finally day 4, which was the day of pouring the slab, the rebars were already completed and the concrete was poured, and it was repeated up to reaching the 156 level. You could visit the video that showed the jumping sequence of the slab formwork system that was used for this project, Burj Dubai project. It illustrates how the slab formwork system works. Leaving the slab formwork system, coming to the concrete pumping, where a utilization of the high-strength concrete and pumping technologies was done. Moreover, selection of the optimum concrete mix design to reach the required strength was taken into consideration for this huge project. Moreover, equipment to deliver the high capacity at the highest level, and the pipeline with the maximum construction efficiency, coordination of the equipment and pipeline to work effectively, and finally quality control maintenance of pumping and placement methods was taken into consideration while doing the concrete pumping. This figure shows the concrete pumping of the project. It shows that Unimix was the supplier of this project, concrete and the center core, and as you can see the wing slabs and the nose columns. Well, leaving the concrete pumping, coming to the final section of the first part of our presentation, the major equipment used in this project. Well, firstly, selecting the optimum equipment and vertical transportation system was a great issue that was taken into consideration in this paper. Coordinating the overlapping activities required a careful planning, analysis, and scheduling, which was taken into account in this paper or in this project. So, beginning with the tower cranes, the self-climbing luffing type tower crane was used in this project. It was located at the central core of the tower. This picture showed the tower crane. As you can see, the Burj as it spirals away, the tower crane is used. And this picture shows that there are 3 tower cranes in the Burj used for this project. As also shown in the picture, the 3 tower cranes helps in assembling the materials. Comes now the tower main hoist. The hoists were installed in 3 different phases, and additional jump hoists were also installed. This picture shows the tower main hoist and the tower spires in the sky. Finally comes the concrete pumping equipment. Pumping the concrete vertically could present unexpected complications, so a secondary concrete pump was installed in case of emergency, and 3 major pumps were placed at the ground level for the concrete to be pumped directly to the highest concrete elevation, which was 585 meters. This figure showed the concrete pumping and the pipeline for the concrete, and here are the concrete pumping at the ground level. Well, you can visit the construction process and see the whole construction process for this Burj Dubai project at this link. As you can see, well, it describes the full construction project with animations, which will be useful for you to visit and see. Concluding our presentation, concrete construction has shown to be as an infancy, where nobody has ever dreamt of creating such a tall building using just concrete. Dubai project has demonstrated that as the technologies advance, the super building won't be a dream anymore. So, Dubai is a step forward in meeting the technological challenges of future in construction of super tall buildings. And finally, Burj Dubai has simply proved that impossible is nothing as the technology advances. The next section is the critique from our point of view. Firstly, the overall paper presents a brief summary of the construction planning of Burj Dubai project, where it states the major facts in the sequence of both design and construction of the super tall buildings. Moreover, the paper presents new technologies that are to be implemented in super tall buildings. Going to the title and the abstract, the title accurately presents the main objective of the author that they wanted to deliver to the readers. The abstract focuses on some internal points on the structural stability of the tower, while it deviates from the main paper objective, which was the construction planning of Burj Dubai project. Coming to the literature review, there was no literature review in this technical paper because it was a state of art. The methodology briefly introduced the new technologies used in tower construction without going in depth of the technologies, which gives an opportunity for future study on certain technologies used in the construction process. Going to the tables and figures. The tables and figures were actually necessary for the paper and to understand, yet some of the figures from our moderate perspective were not serving the paper. Figures 5, 7, which were regarding the concrete planning for the concrete work section, were not necessary to be put inside the paper because I think we all know the creep test and we all know the hydration test. And figure 20, which was the current progress of the Burj Dubai at this time, which could be omitted without compromising the paper's message, which was the construction planning of Burj Dubai project. The results section is not applicable for this technical paper as it's stating facts and concepts for the construction planning of this tower, so there is no results except reaching the schedule at the very tight schedule. conclusions are not logically justified, and they trapped up the paper message. Finally, the elements and objective relationship were related. The elements were actually related to the objective, which summarized the major technologies used in constructing the tower within the very tight schedule. While the paper focused on the construction planning, it stated the structural system in the very first sections used for the readers to understand the construction sequence of this Burj or of this super tall building. Going to paper shortening, the paper can be shortened without compromising its message. For example, the concrete test in the planning for the concrete work section were not necessary to be included from our point of view. The findings, it's clear that the paper findings were illustrated within the paper content. So the main findings for this paper was that any advancement in the technology will result in advancement in super tall structures such as Burj Dubai. We recommend that the abstract focus on the main paper objective without deviations. Moreover, a section for the coordination of the construction mechanical and electrical works should be added to illustrate more this coordination between different works. Finally, there is a minor grammatical mistake on the paper, which was at the time of writing this paper, which was on page 8. I think at the time of writing this paper is much more applicable. Going to the final section, which was the article evaluation. We think that the article has a score of 4 above average quality. It deserves this score from our moderate point of view. I hope you enjoyed our presentation. Thanks everyone for listening, and we will be willing for any questions. For any further information, you could visit us or you can send us emails in this email. Thank you everyone, and hope you are doing well.